Hi all, welcome to Cloud Native Live. Today is Wednesday, May 29th, and we are excited to welcome Nigel Douglas today. Now, this is a CNCF event, and as a CNCF event, we are governed by the CNCF Code of Conduct, so please be nice to each other, keep your comments kind and civil, and we'll all have a great time today. So if you're not familiar with Cloud Native Live, or this is your first time, this is a live stream in which we bring in all the different maintainers and users of different cloud native software and allow them to show kind of how the sauce is made, how everything works. And so with that, I'm going to pass it off to Nigel to introduce himself and go ahead with all the stuff he has prepared. Nigel.
Cool. Thank you so much for having me today. My name's Nigel. I work as a developer advocate or developer relations, whatever way you want to put it. I work with a project called Falco, and my job at my employer, Sysdig, is really just to make sure that users are engaging with the solution, either the way it's intended or to help them change the direction of the project to solve real industry problems. So today's session is really an evolutionary story, and it's how we came into creating a CLI tool called Falcoctl, specifically to address a lot of the day two operations when it came to Falco. It's one thing installing a tool and actually getting it running with some default rules, but operationalizing it to work in production is a completely different situation. So hopefully this session resonates with users who have maybe tried out Falco, have run into issues, and maybe concerned about how they're going to use it in a real world capacity. Moving on to the next slide. What I'm up to these days. As part of developer advocacy, a lot of what we want to do is, again, create content that addresses a lot of the pain points that users are facing. I have a piece I'm going to publish next week on the CNCF blog, and it is, so June 4th will be about Kubernetes or Kubernetes, about the 10th year anniversary of Kubernetes. So it's going to talk through the evolutionary story of the last 10 years of security in cloud native. And I think that'll be a really interesting piece. You just have to look for the writer name really in there. The last piece I wrote was around open source software, and it really ties in a lot of the points I'm making on today's session around, how open source is part of our infrastructure. There's no changing that. And it's actually only going to get bigger. So actually quantifying the value of open source in our economy is a really big deal. And again, if you want to check that out, I think we've got that in the little blurb at the bottom of the page. So with that, I'm going to move on. So we'll set a kind of a clear agenda for today. It's nothing too strenuous. I think this is good for both beginners and maybe for advanced users of Falco. So we're going to talk around life before Falcoctl. So like as I mentioned, it's a relatively new top tool, not as in last month, more like 2 years. But with that, I mean, Project Falco has been going on for many, many years. So the idea of how we operationalized it in the past, shortcomings, and the need for a dedicated CLI tool. We'll talk through some of the basic CTL commands from Falcoctl so you understand actually how I would use in a practical capacity. And then we'll show this scenario of using Falcoctl through Helm. So again, you want to see a real world scenario of installing Falco with specific rules and plugins. We'll talk around all that architecture in a while. We'll show that example and how that works. And then GitOpsing your own Falco rules. So you want to do everything as code. Makes sense, right? You have the rules in YAML manifest. Now I want to take kind of a shift left methodology for updating, distributing our own Falco rules in kind of highly distributed production environments. So yeah, let's get going. So I'll start by talking around the history of Falco and all the associated friend projects, so open source projects of Falco and the ecosystem around Falco. So yeah, Falco started off way back. No, I should say not Falco, but Sysdig, my employer. They started back in 2013. So Falco was founded with this basis of solving problems in cloud native. It wasn't specifically security focused, more so observability in the beginning. So again, there was when Kubernetes came into being, or even just we're talking cloud native, Docker, containers, that kind of thing, prior to Kubernetes, there were all these abstractions that we need to familiarize ourselves with. Before that, we had monolithic applications, and they were long-lived, I should say, with this kind of concept around static IPs, and it was easy to monitor them with traditional tool set. Sysdig solved that problem around containers in the sense that they're now ephemeral, as most people attending today's session will know. So again, not long-lived. The idea is that they could die and be recreated and get new IPs and all of that. And again, we don't need to go into that in today's session, but understanding that Sysdig was built in the world of cloud native, and it's been going since as early as 2013. So with that, we talked around, projects like Docker came into being in 2013. Then in 2014, Google open sourced the project Kubernetes. I think before that it was called Borg internally. Either way, this is now the Kubernetes world that we're seeing now with cloud native. And Kubernetes didn't take long to become a de facto standard for orchestrating workloads. Before that, there were projects like Docker Swarm that were technically competitors, but now it's just Kubernetes. So yeah, then we just saw a pretty quick evolution of organizations wanting to do security in Kubernetes. We realized we had this big open platform, orchestration platform for containerized workloads or actual applications, and we didn't know how to secure it. So the likes of Twistlock, Aqua, StackRox, all these projects come along, and they had, let's say, a pretty heavy focus towards the shift left methodology and securing what comes into your runtime. But they didn't really focus on runtime level security. So it wasn't until 2016 did we see Falco get introduced more as an experimental solution. We wanted to see if Falco could be that dedicated runtime inspection tool for cloud native. There wasn't really a tool at the time that solved that need. So that was great. Falco really solved what it needed to do. And it was actually the basis for my employer creating this managed platform called Sysdig Secure, which was a security platform that users can consume, but it was built on those open foundation of tools like Sysdig Inspect for packet inspection. It had Falco for runtime forensics, intrusion detection. So that's pretty cool. But the open source project of Falco, it's continuing to evolve beyond an enterprise solution that uses an open source tech. The community come back and they say, look, it's great that I can detect threats and show them in a terminal output, or even exporting it to like a syslog output or whatever to a file. But I need more than that. Like, I need to be able to automate notifications. So we want different channel notifications and want all that automated. And that's where Falco Sidekick came to being. So it's a side project of Falco. It has its own UI capability. Again, that's a kind of a dashboard. You can do port forward and see all your events in there. So you can see the project evolves based on community need. So community come back and they say we need tools for automation based on alerting, but also functions as a service outputs. We want to actually kill threats through automation, or we want to be able to visualize all our threats in a GUI with a Redis backend so we can store historic events. That Falco Sidekick came off the back of community demand. Falco CTL was no different. Falco CTL was created on the basis that, great, I have all these rules, but now I need to be able to manage them. I need to, enable, disable rules from specific version control, from previous versions. I need to use only specific plugins, but I need to also have all my configuration of authentication done, again, in code, so that if I'm going to enable a fleet of rules, I want to be able to authorize it and have all this done more seamlessly. So Falco CTL, that is our focus of today. But again, what I want to reiterate here is when we're talking about the 10 years of Kubernetes from 2014 through 2024, Falco's been there throughout this journey, and it's continuing to evolve. When people start talking around CNAP and all these methodologies and how things change over time, Falco's been kind of core in that design of security platforms. And seeing projects like Falcoctl come along this year, it is, continuous recognition from the community that this is what they want to build upon. It's a good foundation to start on. And again, just to conclude on that, Falco, and I barely touched on it, or didn't touch on it at all, is how Falco back in 2018, around the same time Falco Sidekick was devised. Sysdig made a very good conscious decision to donate the Falco project to the CNCF, and that's why I'm here today. And it's only this year in 2024 has it graduated. So it's actually gone through rigorous checks with a technical oversight committee, a due diligence process that involves third-party auditing, all of that to prove that Falco is committed to open source. It has a broad group of contributors, maintainers. It meets rigorous security controls. All the things you would expect if you wanted to use a tool like in your supply chain, in production. Falco has met that kind of gold standard set by the CNCF. So that's I guess a moment for us to congratulate Falco and its achievement there. So from here, Falco is designed with a security-first approach and a distributed architecture to support large-scale production environment. We talked about all that. We see 100 million downloads, 6,500 stars, with 30 plus adopters, so on. So the project also aligns with development models that end users expect from cloud-native software. For example, by providing container images, Kubernetes manifests, and Helm charts. This all being part of an evolutionary story. So, initially you could just build Falco from scratch. Now you're just doing it all in a single line command in Helm. And that's pretty damn cool. It's as people expect Helm 3 charts, we do that. As the people expect a response engine, let's build that out too. Falco is widely used in production, and again, it's widespread use for Kubernetes deployments, including, as it mentioned here, the 30 self-declared adopters. Falco is integrated in a variety of derivative products, whether it be, I mentioned earlier, Sysdig Secure, but also things like Giant Swarm, StackRox, Sysflow, Tarion. There's a bunch of tools that use Falco under the hood. Furthermore, when you do the CKS exam, you actually will have a module as part of the certification process, which is on Falco for runtime inspection. Again, this is tying into that gold standard expectation that Falco's relevance is that it's the thing that you're most likely going to use in production. It's the one that's true and tested over time. And again, that's really exciting because anyone who wants to do security in cloud native, they're more than likely going to pick up the CKS over time. That's Certified Kubernetes Security Specialist. And yeah, again, you're going to cover Falco as part of that. So what am I getting at with all these side projects? So as I mentioned, tracking stars is one way of looking at popularity of projects, but that's all it is. It's popularity. You're looking at someone's gone over and they've clicked, I star that GitHub repository. What I want to show from here is you can kind of, if you're tracking those stars, you can see kind of where the projects came over time, and that more attention is really needed to those side projects. I personally believe that Falco is an incredibly popular tool. It solves a lot of problems, but there's not the same attention given to the other projects that have evolved over time. Like from an observability perspective, I mentioned earlier, you have Falco Sidekick UI, and that's that dashboard, and that's great. You can visualize all your events and get it pretty graphs and so on. More attention is needed there. But again, it's still growing in popularity. From rules management perspective, there's Falco Sidekick or Falco CTL, and that's been there for a while, but hasn't garnered the same kind of interest that you want. And by the way, you can track all these numbers on any repository by going to star-history.com, as I mentioned at the bottom of the page of the slide, and you can just track, how many people are showing interest in a project. And then most recently, the threat detection part. Threat response, not detection. So we already detect threats in Falco. Now you're able to respond to threats in things like Falco Sidekick or Falcoctl, which is a dedicated response engine that's been introduced. So we want to show how the projects have evolved over time. And as we add complexity, it becomes harder and harder to manage it in the ways we used to manage Falco. Now we need a dedicated workflows and CLI utilities to make our life more manageable. So at its essence, I don't see it. The problem is I don't know who is attending the session is familiar with Falco and how Falco works. So I'm just going to quickly explain the architecture of Falco. At its core, there's two options, right? There's a kernel module or an eBBF probe. And what happens is these are like a kernel probe is self-explanatory. It's a probe into your kernel. So by monitoring system calls from the kernel space, we get pretty much full visibility into the system. So imagine you have Kubernetes, and Kubernetes, like you have a control plane node or you have worker nodes. But either way, the node, that's logical server, hosts your pods. And yeah, so like it's running on a Linux server. It has Linux pods. I know it's all abstracted virtualization, but at the end of the day, you want to monitor the system calls directly from the kernel. And anytime a process is created, a file is renamed, a network connection is invoked, these generate system calls. So if we're able to monitor system calls, we're good. We can see deep visibility across the host, the containers, the process that reside in those containers, or processes that are executed off the host that have nothing to do with the containers. So the deepest level of visibility. So we're just talking about the collection from the kernel. Now, those events, they go through this ring buffer, and we use this module called libscap, which is responsible for the event collection part. And this is all done in the user space. So now we're outside of the kernel, and this is great. Libs inspector in INSP is the part that actually does the data enrichment extraction. So we'll come to in our rules in a second, but basically we want to extract specific metadata from those events. And that's what we're actually going to show in the rules engine, but also from the different sources we want to enrich our data. So for instance, a system call on its own will give us kind of arbitrary context of what's going on within the kernel. But let's say Kubernetes runs within that same system and it has its own audit logging service. So if we're able to enrich context across Kubernetes with the system call data, well, then we could give you a much better picture of things like, okay, we know there's this process with this container ID, and that's all coming out the kernel space. But then having, for instance, Kubernetes audit log data, like for instance, a pod context, network namespace, the deployment, any of those abstractions, those literals associated with Kubernetes, correlate that context, and you have a very pretty output that shows you more relevant to what's going on in Kubernetes. How can I fix the problem? From there, the rules engine, we'll talk about that now in a second, and alerting on that insecure behavior. So as I mentioned, there was two different ways of event collection. There's no better option. It's just up to you which one you choose. There was a fear, let's say among some, that kernel modules, they can potentially cause kernel panic, as an example, because it's a piece of arbitrary code. It's loaded into kernel, so it's the brain of the system. And if that were to go wrong, if there was any kind of resource issue or so on, yeah, it could break the system itself. And that's not a good idea. That's actually quite scary. So that's kind of where one of the main reasons why people would have looked at eBPF. It's kind of this like a virtual machine loaded into the kernel. So it's kind of a safer option that wouldn't have that issue of kernel panic. But again, it's good to have both options. There are older distributions of Linux that don't support eBPF, of which you would use a kernel module. And similarly, there's newer distributions that will kind of not want you running arbitrary code in the kernel and therefore want a secure alternative, and they would kind of opt towards eBPF. So we have both ways of collecting event data. That's just one thing we want to cover from an event collection perspective. Now there's the plugins. I talked about Kubernetes audit log briefly, and that's where we take the audit data from the kernel and we can get context around all these abstractions of Kubernetes. But these plugins, they're these gRPC event endpoints, essentially. So I'm probably not saying that correctly, but gRPC plugins. So what this allows us to do is stream events from some arbitrary source, similar to the way syscalls are coming through. And we got this event stream. We authenticate it. We approve the collection of data from a specific endpoint, forward it through the plugins. So through that dedicated plugin. So it could be for GitHub, or it could be for Okta from the cloud provider, like AWS CloudTrail, for instance. I think Google Platform Logs, or whatever the audit log services from Google Cloud, stream those logs through a plugin. And again, you can do the same level of enrichment, so on, or just do reporting on it. So in the past, Falco was fine. Falco has system calls and it's all really easy, and you can do alerts on it and then send the output to std out or syslog for SIM, or to a HTTP endpoint, or whatever it is that you want to send the output to. But as we add more rules, we have now this rules maturity matrix, which we'll talk about in a while, which separates what is a stable rule versus what is a, not so stable. It's incubation. It requires work to make it really work for your environment. This adds complexity. We've made conscious decisions around rules and making sure that they're stable for production. But as we add more and more complexity, as more and more plugins get added, there needs to be a tool to decide how we're going to handle those rules effectively. And that's where Falcoctl comes in. So now when you look at the bottom, it makes sense. Falcoctl can install, for instance, specific plugins. It can follow changes to rules feeds. You can, follow the historical tagging system to those rules and then track for stable rules that work for you and then just install based on those set of rules controls. So this is pretty cool. That's what Falcoctl does at its core. But, why does that matter? So again, rules feeds are really okay. So this is where Falco differs from, say, Tetragon, where Tetragon has tracing policies. It designs a YAML manifest to trace all relevant system calls, and Tracy is no different. It's a tracer, and the name's kind of self-explanatory. Whereas Falco is a rule engine. So for every individual thing that you want to monitor, you create a powerful rule. I'm not saying one solution is better than the other. It's just we need to differentiate that one is a tracer and one is a rule engine. They solve completely different things. So whereas a tracer, you want to trace all the system calls that match that arbitrary context. A rule engine is where you can see it here in the conditional set. You would define, for instance, macros that have like spawn processes or match specific process context, and then say, if I have this logic and it does this and it does something else, and the complexity is defined in the conditions, then give me an output that says something like a terminal shell was created, and give me the specific stripped metadata from the Falco rule. So things like username, user logon ID, process name, container ID, all that deep context. And that could be stripped from, again, the Kubernetes audit log or the system call activity, which is really deep in visibility. And this is where it differentiates from, again, Tetragon and Tracy, where they're following the system call activity. We're enriching it against other audit activity. So for instance, if I have a Kubernetes cluster running in AWS, wouldn't it be very interesting to enrich context between system calls, Kubernetes audit log, and AWS audit logs? So yeah, then you put in arbitrary tagging to give context around, in case for short filtering or whatever, as well as priority to understand, is this a low priority? Is this a high priority? Is this critical type of action? Like terminal shell and container, yeah, it's bad practice in general, but it's warning because it's not necessarily malicious action. Now, I'd mention what those conditions are: spawn process, container, and shell process. On the next slide, you can see what they relate to. And this is where, again, complexity, it matters, but you wouldn't be making changes to the rule. You'd be making changes to those abstractions that are in that condition set. So things like spawn process, from here you say it has conditions. So condition has a process that has conditions. Or sorry, the condition has specified a macro that has conditions. So in this case, you say if the event type is event CVE or event CVE or event CVE at, then we know it's executed action, like, again, terminal shell actions to shell into a container. Then I need to find in another macro what is a container. So I said, and Boolean logic statement, container. The container is saying anything with container ID is less than equal to a host. So it's not a host. And then we're good. That's a container. And the shell process is saying another condition, say, if the process name is listed in brackets a list. So you can see now we're nesting lists inside macros, and the list is it's a physical list of things. So it's like, it could be a list of IP addresses, it could be a list of file names, whatever it be. And from here, we define what are the different shell binaries. So this might scare people initially, but this is the most manageable approach at scale. What you want to do is manage a list of, for instance, IPs, and you wouldn't write out the IPs in the conditional set. That's a disaster. It's not scalable. It's not manageable. So you would create a list of the IPs or file names or whatever it is that you're actually tracking. You define a macro to say, okay, what are these listed items related to? Well, they're inside process name. So we know these are the related processes. And then I want to say, I only want to see if this process is there with a container and it's a shell process, then I know it's a terminal shell and container. And that's one of the more simplistic scenarios. But you can have nested lists in macros or that are inside more macros. You can do all that. But again, as more rules get added, and for sure, if you're running this in production, you're going to have a complex feat of rules. You don't want to create these ugly rules that are unmanageable. And that comes into our rule guide, and we'll talk around all that in a short while. So like I say, we're extending the event sources through this plugin architecture. There's all sorts of arbitrary scenarios that like you could create a plugin for. Since it's an open source project, anyone can create their own plugin. Like people have created plugins for Okta, or I guess the HashiCorp team made the Nomad plugin. My colleague Thomas built one for Bitcoin. Was there a specific reason in mind? Probably, but what I'm saying is as you build your own plugins and build all these event sources for handling different third-party sources, this is more justification for Falcoctl, is way of managing which plugins are running and the associated rules for those plugins. And again, if you're interested in that article about why someone would create a Bitcoin transaction plugin for Falco, you can go to that link at the bottom, which is falco.org/blog. And yeah, that's also been shared on screen. So I'm trying to keep with time. So we have, if you go to tomalabrusius.fr/Falco Rule Explorer, you can actually go to this really cool interactive tool that shows you the maturity, the source, the priority, all of that of every rule in all our third-party GitHub YAML manifests, which is actually, might not sound really important. It's a big deal. Because as we add more plugins, as we add more rules for those plugins, and as we add a maturity matrix, it gets harder and harder to manage all this. So at a high level, the Falco project maintains what we call a community contributed system call container event-based rule feed. And again, this is just one long YAML file of all the rules and macro and lists. It's all in one big file. The maturity stable tagged rules are included in the Falco release by default. So the one I've highlighted, falco_rules.yaml, that's the mature one that we can run with. So everything you see on screen there, they're stable rules. Other maturity level rules are released separately, requiring explicit installation and possible customization to be effective in this case. So you actually have to turn those on. In essence, there's now a dedicated rules file for each of the maturity levels. In the past, it was just one big YAML file. Now it's just one big YAML file per the maturity of it. So as I say, a sandbox file, those rules require a bit more work to graduate. Same with incubating, but like, So incubating are like, there's a bit of work required in order to graduate them. Sandbox are nearly there. Deprecated ones we're trying to move away from. So we had a rule, either it generated false positives or it doesn't properly align with the threat landscape. So we tried to turn those ones off and instead replace them with stable rules. So you can go through all the maturity matrix later if that's something that's interesting, but we're going to talk about it throughout the session, is the maturity matrix. So if you go to the Falco website, to the docs, and you look for default rules, you can actually see all of the rules. Now, what I mean by default is it doesn't mean they're all enabled. Even within the default rule set, not everything. Some are disabled. And that's things like outbound connections to C2 servers, where either it doesn't specify any IPs in a list or it specifies an arbitrary IP. So it's not a real threat-based system. Instead, you would need to modify the IPs. So the new rule typically starts at the maturity sandbox, and in some cases starts maturity incubating. However, it cannot initially be maturity stable. And this is a good thing. This is tied to our governance or the style guide and making sure that we're aligning this with community, that we're not, driving in a direction that doesn't align with end users. So only rules at the maturity stable level are distributed with the Falco release package and live within the established Falco rules YAML file. All rules at the remaining maturity levels can be found in the Falco rules according to their respective levels, and they need to be installed separately. They can be made available to adopters through the same means as the Falco rules YAML file, either by directly retrieving it from the repository or by fetching them via Falcoctl. And adopters in this scenario have the flexibility to choose how they install and customize upstream rules that suit their needs. Now, you see here, like the high-level principles and guide review process that's, for the contributors and reviewers. So as I mentioned there, each rule needs to align with our governance. Now, we document that at github.com project/governance.md, but the Falco project has an independent and self-governing organization, and this was all part of us offering the project. When I say us, Sysdig, donating the project to the CNCF. So it needs to have this kind of self-governing organization as per the CNCF guidelines. The community has worked hard to ensure that the project remains vendor neutral and fosters an open source project with a diverse maintainer group of 5 at least organizations. And that's the way it is today. So the Falco community is composed of those 5 organizations, whereas the other control there I mentioned there about style guide earlier, that's really just saying things like, I mentioned earlier briefly, don't write a Falco rule that says, I need this process and this and this and this, and it's just this big ugly string of a rule, and you're not using things like macros and lists appropriately. What that will probably lead to is, for instance, unwanted resource utilization or other performance related issues, or false positives. Is just breaks, and it's not the way to manage rules. Instead, you should have a static rule, define the macros and lists accordingly, and from there you make changes in the macros and those lists. Those are those nested context, and they're the only things that require changes. So yeah, that's kind of the logic. So to reiterate, we have rules that go through a graduation process of their own, and those are in line with the governance system, that multiple people are overseeing them and to make sure they align with organization's need. And then the other part is conforming with a style guide so that there's not ill-performant rules. And this all came as part of the rule maturity framework, which is the idea that, again, it goes from sandbox to graduation of stable. So yeah, one of the other cool things that's possible is now it's possible for all the Falco rules and plugins to independently verify. As you see there, you have different sources that's connected to, but you're able to independently verify the authenticity of each artifact. So what I mean by an artifact is something like a Falco rule or Falco plugin source. We implemented this feature staying true to the open source nature of Falco. So by design, you do not need to have any specific tool like Falcoctl in order to verify the artifacts themselves. You can actually, they should have already gone through this process already. And you can do it manually with cosign to implement even tighter controls. So in Falcoctl, we use this thing called Orus. I guess some people might be familiar with Orus. It's another CNCF sandbox project. Might have been graduated, but I think it's still sandbox now. And this library manages downloading and uploading of artifacts to container registries. So Orus is an OCI registry, as I mentioned, for managing context like artifacts, images, that kind of stuff, packages, so on. Orus was accepted to the CNCF back in 2021. As I say, I think it's still sandbox, but either way, each artifact type then has its own registry metadata. You can see here things like the names, the registry, the repository within the index file. So the general index YAML file is for Falcoctl. It refers to all the artifacts, things, any modifications you make to them, and you specify that in the metadata. So you can choose to, by default, you can see it's Falcoctl or Falco Security plugins, plugin CloudTrail, but you could use your own repository as a way of source control or whatever of the YAML manifests. In order to verify a keyless signature, we need to know in advance some additional metadata about the type of signature and how to verify its authenticity. And we're adding this data to the registry metadata so it can be published to the index by the pipeline. Again, this is the important part of cosign listed here. So thanks to the importance of projects like cosign, software artifact signatures are one of the software supply chain, SSC, safeguards with a high utility to cost ratio. And again, we factored in all these considerations quite some time ago. And from there, we have a working group that are actually dedicated to implementing these signatures. And they've made it a goal of the Falco project. So again, all this that I'm listing here, the signing and verifying of artifacts, was in order to safeguard against registry tampering. It's the secure by design methodology. So making sure container registries distribute artifacts in a convenient way, allow for easy replication across different environments or providers. And even if one of them is at risk of being compromised, you're still protected from potential malicious applications. So it's a really interesting use case here. Then there's the release pipeline part. So as I mentioned, artifacts like plugins or rules, we sign those with OCI artifacts. As for the diagram you're seeing here, there's 2 distinct pipelines. So there's one is where you update the general Falcoctl index. And in the other scenario, we distribute the single artifact, whether it's a plugin or a rule, it really doesn't matter, to the OCI registry. So again, when we're talking about from an attack surface perspective, as security practitioners, generally speaking, we analyze the attack surface and we look for a threat model, I guess. And in this case, there's different ways you can look at it. So If the source repository is compromised, so will the packages. And if the index file is compromised, so will the packages. And at this point, you can pretty much assume, since all the infrastructure is hosted on GitHub, it's a pretty obvious single point of failure. So of course, knowing all this, the open source repositories act as a single source of truth for our plugins and rules. If an attacker manages to merge malicious code and release a malicious plugin, they'll be able to compromise the users and all of that. So I guess the point here is we want to have a way to know that they are signed and authorized and authentic and safe to use. So yeah, I spent so much time talking around the history. Let's just get into the commands. So you can easily install Falcoctl in a bunch of different environments. So if you're using Mac OS, you can just say brew install Falcoctl. If it's on Mac OS system, like either Intel or Apple Silicon, other than using the brew install, you could actually build from source. Or in the case of like ARM, AMD 64, whatever, you can see up at the top, you can just do curl, download the package, and install accordingly, as long as you install it to the path of user local bin. As I mentioned there's the option to install from source. And there's then, to make sure it's running, you just check Falcoctl version. That's it. So it's super easy to install, and you can run it locally. The output looks something like this. So you say Falcoctl help, and it shows you all the associated commands. There's not a whole lot for this session that we need to focus on. So things like artifact, we mentioned earlier, were things like rules or plugins. And then we'll go through indexing registry in a second. So to start, we want to show users how to install a Falco artifact. So in this case, we're just going to focus on the rules scenario, I guess. Cool. Yeah, we'll focus on the rules. So there's some basic commands here. So the first thing, we need to add a new index to Falcoctl. We download the metadata of the artifacts hosted and distributed by Falco Security Organization, and that are made available via Falcoctl tool. So again, Falcoctl index list, you can see whatever that you've already downloaded. But to get it there, you need to say Falcoctl add, and then add it explicitly from a destination. By default, the Falco destination, Falco Security, is hosted at falcosecurity.github.io. And I'm using the HTTPS to specifically or explicitly set the backend as HTTPS for that index. So you can check the index file by placing the list command, as I mentioned. And then if you need to make changes to it, like upgrade it, you can do that via index update. So it's not automatically updated. Since you have a local cache in this case, you just run the update to update that. And again, similarly, if you have an old version of the rules that you want to change, then you can remove that local cache and then update accordingly with the index remove. As already stated, again, new indexes are configured to be used by Falcoctl tool by adding them through index add. There are no limits to the number of indexes you can add through Falcoctl, which is really important to know. So this is what the configuration file looks like. The index file is, again, it's always YAML formatted, and it contains some metadata about the Falco artifacts. Each entry carries information such as the name, type, registry, repository, all of that kind of stuff for a relevant artifact. Different Falcoctl commands rely on the metadata contained in those Falco index files in order to operate. And as you can see here, you have this index file, and the keywords are things like the different sources. So for instance, audit logs for Kubernetes. These are two examples for Okta. So the first one's the Okta plugin under index. And yeah, it's even type plugin. And the other one's Okta rule, which is the rule file associated with the Okta plugin. Again, you can go to the index.yaml if you want to see the full output of all of it by default. And you can modify. We'll talk about modifying all this in a short while. So yeah, searching your artifacts. So the Falcoctl provides different commands to interact with Falcoctl artifacts. It makes it easy to search, install, and get information from artifacts provided by the given index file. For those commands to properly work, we need to configure at least an index file, as shown here on slide. So in my case, I have the search, and I can see I already have the rule file from earlier. If you want to search specifically for Kubernetes as a matched resource, then you can say, for instance, okay, for that artifact, I have the K8s audit plugin, and I have the K8s audit rules associated with that plugin. Yeah, the artifact search command allows to search for artifacts provided by the index file. As mentioned earlier, it's just that one giant file that has all the associated plugins and rules. The command supports searches by name, keyword, display, all of that context. So no matter how complex it ends up being made, the type is, again, a quick way to search through to find out, okay, these are the relevant context matching that specific plugin or rule. So if I want to find anything Kubernetes related, I can search by that type and find, again, we could be creating our own plugin. So the more complexity added, the more useful it is to search for artifacts. And then you can install it. So this time it's really simple. So to install the artifact, whether it be the plugin or a rule, you need to check the versions first by doing the artifact info. That's really important. So you can see here, when I run artifact info at the bottom screenshot, you can see these tag outputs. Tags are the historical versions. It's, again, the labeling context in this case. So if I want to use an older version that was, let's say, stable for our use case, then I would use index to find what are the matching tags for that Kubernetes audit plugin. And from there, then I can say something like Falcoctl artifact install, Falco rules, or K8s audit rules, : you can see there is 0.5.0, you know? So all these artifacts, they have the floating tags. By default, if you give the name of the artifact without any context around it, I guess it will always show as latest. Makes sense because you haven't specified a version. And the commands accept also the OCI reference as an artifact. So we'll come to that in a while, but that's basically where you're going to like host your own scenario of your own rules feed and install from there. Otherwise, just go to the GitHub project, github.com/Falcosecurity rules, basically the link shown on screen. And from there, you have a visual representation of those old tags. So rather than saying artifact info K8s audit, I can just go to K8s audit and look for the info on screen if you prefer doing everything via GUI. And yeah, the version mapping between Falco plugins and rules is also done automatically, which is really important. This resolves the issue of dependencies, so there shouldn't be any stability issues related to rules and the associated plugin. So you can see in the output, when I ran Falcoctl artifact install and I specified the plugin with version 0.5, you can see under info it says resolving dependencies. So it's saying for the plugin K8s audit 0.5, it should match JSON version 0.6.0, as well as the rules. The rules for 0.5 should meet the plugin version of 0.5.0. And then you can see that throughout it. It's pulling the relevant plugin and rules that are version controlled to each other, which is really great. Then we want to install our plugin. So again, this is exactly the same logic. You're going to find what are the artifacts. So we know that there's now an artifact for, say, the GitHub plugin. So I'd say Falcoctl install GitHub. The artifact follow now, what that does is it checks for updates on a periodic basis and then downloads and installs the latest version as specified through those tags we mentioned earlier. It pulls the artifact from a remote repository, which again is we have Falco security / whatever destination. Yeah, plugins / rule set, whatever that is. So from there, it saves it to a given directory. Then we install the GitHub rules file from that default path, unless the path is otherwise specified. By default, if you give the name of the artifact, again, it searches for the artifact that's configured to the index file and downloads the latest version. The commands accept the OCI reference of the artifact, and in this case, it'll ignore all local index file because we've just said pick it from the remote repository by default. So Helm is another scenario because you're probably looking at all these and saying, okay, do I have to do everything via the Falcoctl utility? Maybe I just want to install via Helm. And yeah, you can do that too. So with this, if you want to manage your rules, we have different modalities. I don't know if I mentioned that in a previous slide. I guess I'll come to those here. The different modalities, which are just the environmental variables you can specify that are shipped with it by default. So these are prioritized based on, it's in a descending order. So things like command line options, then environmental variables, and then finally the Falco config file. So this means that an argument is passed through multiple modalities. The value set in the command line option takes precedence over the value set in the environmental variables, which in turn takes precedence over the value set in the config file. And that same rules apply to this Helm, where we say, okay, I'm installing Falco. And in this case, I installed it into the same namespace called Falco. You can see I've got other things like Falco Sidekick. They don't matter in this case. It's just cool to see installing all the relevant add-ons via just one single Helm install command, such as, again, Falco Sidekick, the associate plugins, or storage backend, the webhook for integrating with Falcoctl. But in the case of what's highlighted in green, you must install the modality of install reference of the rules repositories. So I want to have the Falco rules, the incubating rules, so stable rules, incubating rules, sandbox rules. And once I define those, then in the same order, I need to specify the rule files, which are the matching rules in that order, which it should be Falco_rules.yaml, which matches to Falco rules. The Falco incubating _rules.yaml matches the Falco incubating rules, and so on. So it has to be in that order and ends with the custom rules, which is other arbitrary rules that you just write into a YAML file. You can host that anywhere and just install those as well. Yeah, and this is somewhat different again. So on top of any scenario that we mentioned there, you can add the custom rules file to add other custom rules too. And yeah, so they're going to the config map, and we'll talk to that in a second. So if you write custom rules, they'll go into a dedicated config map of all those additional rules you're writing. Custom rules, you can write anything you want, but those are different to those rules maturity, where we're talking about rules that were managed by the community project itself. And then if you don't want to use this, you can just set false on those set fields. So Falco already has a snapshot of the latest version of those rules. If you wish to use whatever you have by default and don't want to, you don't want to be dealing with specific version controls, of those different rules, you can just disable that artifact that's related to it. And yeah, that's fine. You can write all the rules in the custom rules file if you want. Then there's the need to GitHub everything. I think we have a few more minutes. So far, there's no major questions coming in chat, so that's okay. The next part is automating the lot of it, through Falco CTL. So again, we have a blog on falco.org called GitOps Your Falco Rules. We wrote this blog about using known CI/CD techniques in order to pack the rules in a distributable object. So something that you can just ship off and have this automated in production. So there's two scenarios. Maybe you prefer to stick to a stable version, and that's fine. You can just continue to use the stable version stuff. Or maybe you want to be flexible about the offerings around multiple versions, and that makes sense as well. There may have been rules that worked in the past, and any changes might cause false positives going forward. So you're comfortable with the old versions of the rules and therefore need that old flexible tagging versions. So combining the power of Git with the standard of OCI, Falco is able to selectively retrieve the most suitable rules for each platform. In order to achieve this, what's specified, we need an empty GitHub repo. We need an existing rule set, as well as that we need to have the Falco installation file. Now, the tutorial uses both in this case scenario. So Falco is running as a systemd service. So we're not installing it. Oh yeah, sorry, yeah. So we have it running as a systemd service. And also we have it deployed using a Helm chart on Kubernetes. So obviously there's a need for the container registry. The blog mentions using GitHub packages, since that's coming public for free with GitHub repositories. So at the high level, you create the empty GitHub repo, you upload your rule set. It's a single file, it's absolutely fine. You configure GitHub actions to generate and publish the OCI artifact. And then finally, you can test it. Again, test whether or not the Falco CTL-based distribution automatically reloads at the updates of those rules. And if it does work, then great. You can have this kind of GitOps automated workflow. From here, customizing the Falco CTL config map, like I mentioned earlier, it comes out as when you write those custom rules or whatever, it comes through as a config map object. So we have the default configuration installed by Helm when deploying Falco and Falcoctl. If you run the kubectl logs output for the pod with the specific container being Falcoctl artifact follow, you can see, for instance, context like if there was a index configured. If not, you'll say consider configuring one with index add. But it'll also say, look, where are we following it from? So like it created a follower for the default stable rules. It's checking it every 6 I think that's 6 hours. Yes, 6 hours by default. Oh yeah, it also says it on screen, 6 hours. So if you want to make changes, you didn't want to take the rules from the default rules specified by Falcoctl repository, you can do this. You can then say, okay, that's not 2 minutes, that's also 2 hours. So you can make the change in the bottom. So when we were talking about the config map, if you were to say kubectl get output in YAML, or kubectl edit in this case, the config map, you could change the reference from falco-rule 0 to ghcr.io to wherever you're hosting it, which is Nigel Douglas, whatever the directory is called, with the custom rules main. And similarly, I can change the follow to say, I want the updates to be checked for every 2 hours rather than every 6 hours. And that's the difference. That's essentially it. So once you have it done through GitOps workflow, you can then specify your own secure, stable location for taking those rules and manage it all in your own ecosystem. And with that, I'm leaving it for Q&A. I don't know how much time we have left, sorry. So I just want to make sure that this session was valuable for those who are attending, or if there's any outstanding questions.
Awesome, thank you. So anyone participating in the stream, feel free to ask a question. While those roll in, I did have one for you, Nigel. And how do people get involved with creating plugins and rules? You kind of showed some of the ways it gets deployed and all those kind of things. Like, what's kind of the way you can start getting involved with creating those?
Yeah, and this is the funnest part, I think, about the Falco website is if I close out the slide deck and I'm going to go Control F and we just go to falco.org, maybe just go to falco.org, like the landing page. And from here, if you wanted to check out our docs, Falco's very heavily focused on the developer community. So what we'll do is, rather than focusing, I mean, you can have pros and cons of each effect, but we will talk around things like install and operating, creating your own plugin, creating things from source. So if you are looking at plugins, and you can obviously use it, but maybe you're more interested in actually building it. So you can just skip straight to developer guide, and then there's a section on how to develop a plugin from scratch. And you can actually look at, okay, they give you the defined Go SDK. They give you some guidance on how to create this gRPC plugin. And from there, you can say, okay, what is the relevant source of data that I want to collect it from? Is it from an identity service? Maybe not Okta, because that's already done, but maybe you have one identity or something else. So having this kind of developer-focused plugin guide on how to build plugins and stream events from third-party sources is pretty darn cool. Because I would say the Falco website is very heavily focused towards the actual developers of plugins and rules, and being very much developer-focused.
Okay, awesome. Now, as a follow-up, one of the interesting things about the Falco project is that it has its own, inside of the project, levels of graduation, essentially, of these rules. What should people expect that graduation process to look like? I know that people, when they get involved, especially with security things like this, they're very passionate about it, so they want to know probably how these things work. Is there a general place they can go to understand those guidelines?
Yeah, absolutely. I think I had a page on this. Maybe I don't. But if we just look up rules maturity framework, Falco, the reason, all this should be public. So if we looked up the adoption of Falco rules, and I guess maybe from here go to the rules maturity framework in GitHub itself, there's usually, like I mentioned briefly in the session, making sure, first of all, the rules match the style guide. So there is a very clear style guide on how to create rules and make sure that they address the design of how rules should be created. Then they talk through, again, obviously, the idea that they'll start off in kind of stable and then they go through a graduation process. But what I will say is it's pretty transparent, the maturity matrix and how to work with developers and community. If you're making a PR, for instance, against the project, you can go into comments within GitHub and say, look, we solved this kind of core problem. I would like to graduate it. And they say, yeah, brilliant contribution. Or they'll tell you, look, it's not really in line with the style guide. Can you make these appropriate changes? They might even guide you in the right direction to make sure it does address the style guide. And from there, it follows the maturity matrix. But if you've been vetted by the Falco maintainers and they say, look, this is a good rule, but you're waiting for it to graduate from sandbox into stable, in the meantime, you can just put it into custom rules file and start running it right now. It's not like you need to wait for it to graduate to a specific rules file in order for you to use it. In fact, if it started off in sandbox and you know it's good to go, well, then just turn on that sandbox rules file and use it from there. And that's the other side of it as well, is if we go to stable rules, like I say, can we look at default rules? You'll see some of them are disabled or enabled. So you can also append to say, for instance, disable this rule that I don't want, or enable the rule I do want. So all of the ones that are, let's say, disabled, we could say, I would love to see this one being enabled about outbound connection to C2 server. I know what changes I need to make, which is adding specific IPs to the C2 full qualified domain list, and just append it to say, instead of being disable, enable. But there's probably a reason it's deprecated, because it was replaced by a better designed rule in the stable list. Well, actually, sorry, this is the stable list. So I'm not sure why that has maturity deprecated. We'll come to that in a while. But does that make sense?
Yes, that does. Thank you very much.
Cool.
Okay. Well, I don't see any other questions that have come in, so I think we'll go ahead and probably just wrap it up now. Thank you so much for coming in, Nigel. This was really great to kind of get this overview of such a widely used project. If anyone's interested, is there anywhere they should reach out to people in the community?
Yeah, I would say the best place, obviously, if we go to community and about the community, you can obviously follow us on Twitter and LinkedIn, as you see here, but the best place is the Slack community. So if you go to Kubernetes Slack and you look for the channel #Falco, we're all there. So that's a great place to meet, chat, talk about anything related to project, issues you're facing. People are more than happy to help. And if it's just things like governance and contributing to plugins and so on, then you can drill in straight to the GitHub repository and get involved. So yeah, those are all the options today.
Okay, awesome, great. Well, thank you so much, everyone, for attending today. Thanks again to Nigel, and we'll see